And one question you might have while we're going through Lewis structures for molecules and talking about covalent bonding is for polyatomic ions like the carbonate ion or the nitrate ion, and we've drawn a Lewis structure for the carbonate ion, what does the charge physically mean? We know it's got extra electrons, but does it have extra electrons? So where does that actually come from? And also, where is the charge actually located? Or is it located anywhere? Is it just spread all over the molecule? Or where is the charge located in an ion, in a polyatomic ion such as carbonate or nitrate? Well, having a charge simply means that we have either more or less electrons than the sum of the valence electrons of the constituent atoms. So in these anions here, we have 2 extra valence electrons for the carbonate, 1 extra valence electron for the nitrate, 1 more or 2 more than the sum of the valence electrons of the individual atoms. And of course, more means that we have a negative charge unless we have an anion, or less means we've got a positive charge and a cation. So how do we go through and sort of keep track of that when we want to talk about where that charge is located or what that means? Well, we use something known as the formal charge. And every atom in a molecule has a formal charge. It might be 0, but every atom can be assigned a formal charge. And the formula for it is simply the formal charge for an atom is the number of valence electrons for that atom, the normal number for just the atomic element, minus the number of bonds that that atom has in the molecule, minus the number of non-bonding electrons. Those would be the electrons in lone pairs. So what does this look like as examples here? So let's take the cyanide anion, Cn-. So if we draw out its Lewis structure, it's carbon with a triple bond between carbon and nitrogen, and then the carbon and the nitrogen both have lone pairs. So they have a full octet. We know that the whole species has a negative charge, but where is that negative charge actually located? Well, if we go through and just follow this process, what we can do is assign a formal charge to each of the atoms. Let's take a look at carbon, for example. We see here that we've assigned a -1 charge to it. Why do we do that? Well, let's follow just the formula. Formal charge is number of valence electrons. Well, carbon's number of valence electrons is normally 4 for its just in its atomic state, minus the number of bonds. Well, it has 3 bonds here, triple bond, so minus 3 bonds, minus the number of non-bonding electrons. So these are the electrons in lone pairs. It has 1 lone pair, and that lone pair has 2 electrons in it. So there are 2 non-bonding electrons. So 4 minus 3 minus 2 is -1. Nitrogen, on the other hand, has 5 valence electrons, minus 3 bonds, minus 2 electrons from that lone pair. So it has a formal charge of 0. So in this process, what this allows us to do is essentially assign where that extra electron is in the molecule and sort of pinpoint the charge on the individual atoms in the molecule. So we can see the charge here is located on carbon. Although we may talk about the whole unit having a charge, we can assign the formal charge to the carbon atom. Now, a couple other examples we can work through here. And one is the carbonate ion that we'd done previously. So, and the other is an actual cation now. So this indicates that we're missing 1 electron, known as the hydronium ion. So if we start with that first, and I'll just quickly draw out the Lewis structure for it. The hydronium ion, if we follow our rules, will end up looking like this, where the whole system has a positive charge. But then we go through and say, well, where is that charge actually located? Which atom is essentially missing an electron? Which atom does the charge reside on? And if I go through and take and say, well, all of the hydrogens appear similar, so the formal charge of one of them should be the same as the other. So I'll simply take this first one. hydrogen has one valence electron, minus, in this case, one bond, minus number of non-bonding electrons. It doesn't have any lone pairs, so that would be 0. So 1 minus 1 is equal to 0 for hydrogen. And so hydrogen has no formal charge in this case. Its formal charge is 0, and same for the other two hydrogens. Oxygen, on the other hand, though, 6 valence electrons, minus 3 bonds, minus 2 non-bonding electrons from its one lone pair, and we come out with a positive 1 charge here. Thus, we can assign a +1 formal charge to hydrogen, not to hydrogen, to oxygen in this molecule. And what about cases where I have multiple charges, like CO3 2-? What does that look like? Well, drawing out our Lewis structure, remember we've drawn it out like this for the carbonate ion. And I can go through and simply assign the formal charges for each of the atoms. So this oxygen on the left, 6 minus number of bonds is 2, minus unshared electrons, there's 2 lone pairs, so that's 4. That oxygen has a 0 formal charge. Carbon, 4 minus 4 bonds, minus, it has no lone pairs, so 0. It has a 0 formal charge. This oxygen on the top, however, 6 minus 1 bond, minus 6 unshared electrons, it has a -1 charge. And this oxygen on the left, 6 minus 1 minus 6, it also has a -1 charge. So what we see then from this is that the charge in the carbonate ion resides on 2 of the oxygen atoms in this structure. We'll see a slightly more clear picture a little bit later when we talk about resonance structures. But for now, we can assign that charge as being -1 charge on each of those 2 oxygen atoms. So let's just go through and work a few more problems quickly. We've got the ammonium ion, we have whatever OF3 plus is, and we've got NBR2 minus. Well, first I'll just go ahead and, following our rules, I'll quickly sketch out the Lewis structures for each of these molecules. So NH4 plus is simply N bonded to 4 hydrogen atoms, and that uses up all those electrons. Oxygen is bonded to 3 fluorine atoms, and it has a lone pair. Each of the fluorine atoms has 3 lone pairs around it. And then NBR2, that's BR, 2 lone pairs, and then lone pairs around each of the bromines. So if I go through and assign formal charges, let's just start with hydrogen up here in the first compound. So hydrogen, 1 valence electron, minus 1 bond, minus 0 unshared electrons because there are no lone pairs, equals 0 for its formal charge. So hydrogen, none of the hydrogens have a formal charge. Nitrogen, on the other hand, 5 valence electrons, minus 4 bonds, minus 0 unshared electrons, there's no lone pairs, gives me +1 for its formal charge. And so I can assign the charge in this molecule as residing on nitrogen. The OF3 plus, I can do fluorines. All of the fluorines should be the same. So fluorine, 7 valence electrons, minus 1 bond, minus 2, 4, 6 unshared electrons. That's also 0. Meanwhile, oxygen, 6 valence electrons, 3 bonds, 2 unshared electrons. It has the +1 charge. And so I can assign the charge in that molecule as residing on oxygen. NBR2, well, the bromines, similar to fluorine, 7 valence electrons, 1 bond, 2, 4, 6 unshared electrons. That's 0. Nitrogen, on the other hand, 5 valence electrons, minus 2 bonds, minus 4 unshared electrons from the 2 lone pairs. There's our minus 1 charge. And so we can assign the formal charge as residing on nitrogen in this molecule. So that's how we go about assigning formal charge and identifying which atom in an individual molecule carries the charge in that molecule.